we were presented with a system of three linear equations, and we were asked to solve this with matrices. So what we did is we found a matrix, a coefficient matrix, right here, and then a vector matrix, meaning we rewrote the left-hand side as matrix multiplication and the right-hand side as a vector. Then we recognize that we have this form over here, and that if we want to solve this form, what we want to do is we want to find the inverse of A, such that on the left-hand side we get I, and on the right-hand side we just get the A inverse times the vector V. And so now what I'm going to show you is I'm going to show you two methods to finding the inverse. Actually, three. I'll show you one using the adjoint theorem, the other one using an augmented matrix, and the third one just using the inverse function that's present in MATLAB. So let's go. Okay, so this is going to be a new exercise here. Let's say this is exercise 49. First thing I'm going to do is I'm going to clear all the old variables, and that is done by the command clear all. Then what I'm going to do is I'm going to define a new matrix. So that's going to be A is equal to 1, 0, 1, 1, 1, 1, 5, negative 1, and 0. This is my new matrix. And the first method that I'm going to use, I'm going to say it right here, adjoint method. And the right-hand side was vector v. I'm going to define vector v as well, which was negative 4, 0, and 6. All single entry rows. So for the adjoint method, what are we going to do? Well, for the adjoint method, the first thing we want to do is check that if A is invertible. So determinant of A, and we'll call this D. And if we let it go, see, we have something that is less than 0, so that it's not equal to 0, which means it's invertible. Now what we're going to do is we're going to find the adjoint, finding the adjoint of A, and there's a nice command, adjoint, right here, and I'll call it adj here. And basically what the adjoint is the cofactor expansion of A transposed. Okay, so let's see here, we have an asterisk. Don't know why we have an asterisk in there. Let's see here. We have these and these and these. Well, let's keep going. Let's see what happens. Then, finding the inverse of A, what we do is we say that A inverse is going to be equal to 1 over D times the adjoint. And for some reason we get carried that asterisk over there, which I am not really sure what it's doing. So now that we have this, another way to finding the inverse is using the augmented matrix. So the augmented matrix would have our original A, which I'll call B at this point, but then it's going to have what that equals to. So that's going to be negative 4. This row is equal to 0. This row is equal to 6. But that's not, sorry, I made a mistake. It's not equal to the number. It's going to be equal to an identity matrix of the same size. So this is going to be 0, 1, 0. And this is going to be 0, 0, 1. right, like this, right? And now what we're going to do is we're going to finding the inverse of B with reduced row echelon form. And what we find is this. So this is our reduced row echelon form right here. So we notice how that asterisk should be a 0. And so this is a good way to keep track of everything. I'm still not sure why here it's outputting the asterisk. And then what are we going to do? Then we're going to solve for the vector v. So to solve for that vector, now we need to multiply, well, actually it was the vector x. We need to multiply the A inverse times the vector v. And so we know what A inverse is. A inverse is this matrix right here. So let's, and a third way, actually, finding the inverse of A with the built-in function. This one would simply be inverse of A. And notice how we get this. Let's see how it defines this one real quick. This one's defined correctly. For some reason, it just gives us this value right here. And right now, let's see what the variables are doing. So if we do the inverse of A, and we look at it, what we get is something very close to 0. Okay. So let's go back over here. And now we want to solve for the vector x. What we're going to do is we're going to multiply that inverse A inverse times the v vector. And this is going to give us our x vector. So if we do that, we get that our x vector is 2, 4, and -6. And that should be our final answer. Now to verify that that's our answer, what we could do is we could see if I multiply A times my vector x, do I get my vector v? Well, what was our vector v? -4, 0, and 6, and we do indeed get that. So we know that that is the correct answer. So this one would be the verifying the answer step. Okay, well, I hope you understand, and I'll see you next time.